Our team developed a device in collaboration with the Sanger Lab at USC to analyze wrist angle measurements from a prompted user interface coupled with EEG signals in patients with dystonia. The Sanger Lab, under the direction of Dr. Terence Sanger, aims to use engineering principles to understand childhood movement and to discover new treatments and enabling devices that will improve motor function in children with developmental disorders of movement. Our device helps achieve this mission by providing a quantitative platform for the desired signal output as well as an adjustable and versatile hardware setup specifically designed for Sanger Lab patients. This device will be used in conjunction with patients who have electrodes placed in their brain to allow for the quantification of preferential neuronal activity for movement modalities.
Alright, so in order to put the subject in the device, we start by opening up the hand clamp and locking it in place. And then once that's ready, we'll have the patient go ahead and put their arm through these two straps for the two upper arm stabilizers. And this one is adjustable so we can make sure we have it right in the right place. And so once you're satisfied with those placements, you're going to go ahead and strap in the upper arm into the location that we want strapped in. And we're going to use this handbrake to position the hand clamp in the perfect position to where the rotation is right at the wrist joint. And so once we're happy with that placement as well, we'll lock that in place. And then we will undo the locks on the hand clamp, make sure that it's nice, secure, and snug, and then the patient is ready to start the trial.
Okay, here we have our front panel. Going through it, we have our 3 test buttons, a stop test if we want to end the test early, and end program to stop the program from running entirely. This is our wrist angle chart, which will show the 2 target bars and the patient wrist angle data, a score which increases if you stay within the lines, and our stoplight. Going through the first test is our ramp test. And so we'll enter our patient ID 001, and then we'll pick a speed. After I click OK, it'll go red, yellow, green to tell the patient when to go. And so they want to stay in between these 2 blue bars with this red one. And if they go outside, it'll go from green to pink. We'll click OK and go with our sign test, so patient 001 again. And then we'll have our speed be 2. And so this test will oscillate back and forth. I'll go ahead and stop it early. And then finally our last test is our step test. And for this one, we choose how many degrees we want the wrist to move instead of the speed. And so we'll go from 0 to 45 degrees. And then they have to move it instantly, as fast as they can, and as accurately as they can to the correct target. So now we'll go ahead and end our program.
From the data manipulation front panel, the user can select the file to view. Here's the step test. Sign test. And the ramp test that we just performed. On the top left corner, test information including subject number, test name, speed, time, completion, and accuracy is being displayed, and the standard deviation is also calculated by the program.
We are particularly proud of the hardware component we developed for our device. We made all of the stabilizing components in SOLIDWORKS and printed multiple iterations to achieve the final product. It is adjustable and versatile to allow for patient specificity as well as being kid-friendly with the fun design to cater to the young patients that will ultimately be using it. In addition to the hardware, we are also proud of the user interface we created. We successfully managed to prompt the user, but we also added in unique features like the score counter and color indicators when the user is within or not within the correct range.
The last semester, we've been able to successfully create a device that cues wrist movements visually, provides real-time feedback for the patient, assesses the accuracy of these movements, and then displays and exports that wrist angle data measurement. And we're really excited to see where this project goes and how it helps to contribute to the breadth of knowledge regarding childhood movement disorders, and really being able to better characterize how specific movement types and movement modes correlates with different brain activity. Thank you for watching, and fight on!